Hello, Year 11. Today we're going to be going through exercise 2.9 and 2.10, which is all about factorising trinomials. So we're going to be looking at the two different types, monic quadratic trinomials and non-monic quadratic trinomials. So let's start off by looking at our monic. And remember what a monic quadratic trinomial is? It's a quadratic trinomial or a quadratic that has a 1 in front of the x squared. It's what I like to refer to as the simplest of all of the quadratics that we factorise. So what we need to do when we're factorising quadratics is we need to focus on this last number first, and then we focus on that middle number there. And what we're doing is we're saying what numbers multiply together to give 2, because that's our last number there. And the same two numbers need to add together to give 3, because that's our number there. So we want numbers that multiply to give 2 and add to give 3. And the only numbers that I can think of that multiply to give 2 and add to give 3 are 1 and 2, because 1 times 2 is 2 and 1 plus 2 is 3. So when we factorise it, we know that the two numbers we're interested in are 1 and 2. So I can write my brackets in either order. The x plus 2 could come first or the x plus 1 could come first. It doesn't matter as long as I've got those two brackets. My trinomial is now factorised. Let's go to our new one. Now I don't want to write this down, I'm just going to say it now. I'm looking for numbers that times to give 35 and add to give 12. So numbers that times to give 35 are 1 and 35. 2 doesn't go into 35, 3 doesn't, 4 doesn't, 5 and 7. 6, 7, that's it. They're all of the pairs of numbers at times to give 35. And which of those pairs multiply to give 35 and add to give 12? Obviously 5 and 7. So the answer is x plus 5, x plus 7. Now obviously when you're doing these, there's no need to write all of this part here unless you're getting a more difficult question and you have to. You can just write the answer down straight away, and that's what we're encouraging. Okay, so let's see if we can get the answer down straight away for this one. I need numbers at times to give, whoops, let's undo that. I need numbers that multiply together or times to give 21, but they add to give negative 10. Now I know 3 times 7 is 21. And 3 plus 7 is 10. So because I want them to add to give negative 10, my two numbers are going to be minus 3 and minus 7, because minus 3 times minus 7 gives plus 21, and minus 3 and minus 7 add to give negative 10. Next one, I need my numbers to multiply together to give minus 20 and add together to give positive 1. So the numbers that I'm going to be interested in will be 5 and 4, and I'm going to go for plus 5 and minus 4, because 5 times minus 4 is minus 20, 5 take 4 is 1. Now I'm looking for numbers that multiply to give minus 45 and add to give minus 4. Now I know 5 9s are 45, so that's probably what I'm going to be looking for. Let's try this. Negative 9 times 5 gives negative 45. Negative 9 and positive 5 add to give negative 4. There's my answer. Right, now let's go on to the harder trinomials. Why are these harder? Because there is a number in front of the x squared. So last year, my class were taught you could do this two different ways. So let's go through the two different ways. Let's call this one method 1. And so what I've got to do before I start is I've got to look at my question, and 2 and negative 1 are my outside numbers, and they times together to give negative 2. So I want numbers at times to give -2 and add to give +1. And so the numbers would be 2 and -1 because they multiply to give -2 and they add to give 1. So if I use method 1, I'm going to rewrite the question, but this middle term is written differently. Instead of writing +1x, I'm going to write +2x minus 1x. And where did I get those numbers from? +2x minus 1x. So from over here, the +2 and the -1. Now that I've got that, I can actually look at the question and I can group in pairs. There's my first two terms. If I look at those, they have a common factor of 2x. So what's left? X plus 1. And if I look at my last two terms, they have a common factor of -1, which will leave me with x plus 1 left over. Now when I look at the question, I have a common bracket. There's my minus sign separating my first term and my second term. The common bracket is x plus 1, and the leftovers are 2x take 1. So there's method 1, using grouping in pairs. Let's use method 2 now. So we'll come up with method 2. So when we're doing method 2, we cheat a little bit, but first of all we still need to know, okay, we're looking at our outside numbers. 2 times -1 is -2. I want numbers at times to give -2 and add to give +1. And so they're the same pair of numbers we had in method 1. They're going to be 2 and -1. So they're our numbers that we're going to deal with. When we're using this method, method 2, what we do is we put a pair of brackets over. Now, this is the part we're focusing on. What's the number in front of x squared? In this question, it's a 2. So we're going to start each bracket with a 2, and we're going to divide it by a 2 because that's what was in front of the x squared. So we put 2x over 2, and I come over here and see my numbers are 2 and -1, so I'll put +2 -1. Then I look and I see that the first bracket, everything can be divided by the 2. So I go, the 2 is going to go into the first bracket once and once, which leaves me with an answer of x plus 1, 2x take 1. Finished. There are our two methods. Let's go on to 2b. Rightio, we're looking for our outside numbers. We've got 9 and 2. 9 times 2 is 18. So I want numbers at times to give 18 and add to give 9. What are numbers at times to give 18 and add to give 9? 6 and 3. Now I'm going to use method 2 to do this question. Notice in front of the x squared there's a number 9. So I'm going to put 9x plus 6, 9x plus 3, all over 9. Where did I get the +6 and the +3? From my two numbers. Where did all the 9s come? Because of that number there. Now 9 doesn't divide nicely into both brackets, so I'm going to think of that 9 as actually 3 times 3. And I'll divide this 3 into the first bracket, and I'll divide this 3 into the second bracket. And that will leave me with, when When I divide everything in the first bracket by 3, I get 3x plus 2, because 3 goes into 9 3 times, 3 goes into 6 twice. 3 into 3, 9x, 3 into 9 goes 3 times, 3 into 3 goes once. Finished. There's my answer. You could also use method 1 with grouping in pairs.